In this experiment, the entire idea was to basically test the effect of various amounts of water in various different sized bottles. Essentially testing to see if a wider bottle would make a louder frequency, and ultimately proving if adding more amounts of water would decrease or increase the frequency. Our hypothesis stated that if we conduct an experiment regarding the size of the glass to the volume and the effects water has, then the largest glass with the least amount of water would have the highest frequency due to water's inability to oscillate as freely as a solid. To start this experiment, I want to go over the background information. All this information is derived from the 16.1 synthesis and figure 16.19 from the book. For starters, I want to go over the basics of what is a wave. A wave consists of nodes and antinodes, where the nodes are where the waves meet and the antinodes are the peaks and low point areas of the wave. The open-closed tube has a node at one end and an antinode at the other. Only odd number antinodes are possible. And to determine this mode number, one would simply have to imagine doubling the length at the closed end and count the antinodes. What the important information is here is that the fundamental frequency of an open-closed tube is half what we would expect for an open-open or a closed-closed tube, assuming they had the exact same length. We use 4 times the length instead of 2 times the length in an open-closed tube, which is why the frequency is halved compared to the other tubes. Now that I have the background information settled, I now want to go over what the variables are. The dependent variable is the frequency of each bottle, and the independent variable is the 3 glasses we had, which did not change throughout the entire experiment. We needed a way of measuring one glass versus another, and we determined that volume would probably be the best way of doing this. Bottle 1 had a volume of 51.7 inches cubed, Bottle 2 had a volume of 89.8 inches cubed, and Bottle 3 had a volume of 228 inches cubed. To simplify that, Bottle 3 had the greatest volume, so according to our hypothesis, it should have the greatest frequency with the lowest amount of water. From here, we blew inside the glass to produce a vibration, which is an oscillation down the side of the solid and in the water to produce the sound that we hear. To recap, according to our volumes, Bottle 3 should have the greatest frequency and Bottle 1 should have the lowest. The order of most, or from least to most, being 1, 2, and then 3. And with this experiment and plan, we got actually some really good results. On the screen, you'll be able to see our data laid out. With all the bottles, we put in 1 tablespoon of water into the first trial and 1/2 cup of water, precisely measured, out into the second trial. For the purposes of the data, trial 1 will be regarded as the one with 1 tablespoon of water, and trial 2 will be regarded as the one with 1/2 cup of water. For bottle 1, trial 1 had a frequency of 250 Hz, and for trial 2 had 198 Hz. For bottle 2, trial 1 had 396 Hz, and trial 2 had 49 Hz. For bottle 3, trial 1 had 500 Hz, and trial 2 had 250 Hz. Now, to get away from numbers, I wanted to go shortly over what all this information means and attempt to conclude this. According to our information, it seems that the largest bottle actually did produce the loudest frequency. Not only that, adding more amounts of water significantly dropped the frequency on most of the trials. From this information, we can derive that water does lower frequency in a bottle. The first takeaway point from experiment being that a glass with less water will always produce a higher frequency than one with water. The second takeaway point being that generally, as you increase the size of the volume, the frequency gets louder. And this is assuming that all the bottles or glasses are, similar in shape and the grooves are similar, to just eliminate any variables that would ruin it. And that was our experiment. Thank you guys so much for listening, and I hope you have a wonderful, fantastic, and a certain vector fun-filled day. Thank you.